Hi, I'm Tim Titus, Chief Technical Officer of PathSolutions. I'm going to dive into a demo of how TotalView ends up making network operations, telecom operations, and security operations a lot better and easier in an environment. So let me dive into our deployment. So you install the software. It's an 80 megabyte installer that installs on any Windows operating system. And I truly mean any. You can put this on server operating systems. You can actually deploy this on desktop operating systems if you want to walk into a customer's environment and do an immediate troubleshoot. So it's got a lot of flexibility with where you can deploy it and all of its use cases. You deploy it, and it's going to immediately scan the network using SNMP, and the SNMP we support is V1, V2C, V3, and also Cisco's high encryption mechanisms for V3. So AES 192, AES 256, and Triple DES are supported. We're going to go out and find all of your switches, your routers, your gateways, your servers, anything on that network. We're going to automatically find them and then start picking up all sorts of information. The information we pick up is highly automated. It's going to pick up that information, including error counters, configuration, performance, far more information than what you get out of any other tool, so that we can start putting red dots in front of things that we find as broken. So a few minutes into deployment, we find there's a red dot in front of the Syrah switch. So we can click into that switch and see what's going on. As soon as we click in, we're going to see all of the interfaces on that device. Very quickly, we see interface 5 has a red dot, and we see that there's 4% packet loss on that interface. Now, if I told you, hey, we found packet loss on a switch port, you might say, well, so what? If that's a printer or a photocopier, most people couldn't care less. If this is a Voip phone, or this is a trunk port to another switch, or there's a critical server here, then yeah, that's a high priority problem. So to help identify what is affected by this packet loss, we expose all of the CDP and LLDP information, if any is present on these ports. So you can see upstream connected phones or switches or routers. We also have a fully integrated port mapper. Click on the Connected tab, and we're going to tell you what the switch sees as connected there. Here, we have one MAC address. That one MAC address associates with the HQ voice VLAN, VLAN number 110 in our environment. We see the MAC address and realize that this is a Dell computer. We see the IP address. We see the reverse DNS, and we can say, hey, wait a minute, this is our voicemail recording server? If that's where the packet loss is happening, that's bad, because having packet loss with a voicemail server just means choppy voicemails. So I'd say this is a high priority problem. Let's see what's going on. We click into the interface. What we're going to see is we're going to see the utilization graph, and we're going to see the packet loss graph. Below that, we get to see the prescription. This is giving us a plain English prescription of what's going on. In this case, we've identified there's a cabling fault. So it's that fast and easy to recognize that we have a problem on the Syrah switch, we have a problem on interface 5, the problem relates to packet loss, it affects this voicemail server. Here's when the problem started, here's when the problem stopped, and here's what the problem is. Now, something to recognize is that other monitoring systems might say that this interface is perfectly healthy. They're not aware of this problem, and they're going to say, nope, there's no packet loss according to their product. We're going to tell you the truth, though, and here's what the big difference is. If you click on View Error Counters, it's going to show you all 19 of the error counters that we're picking up and analyzing. Other monitoring software packages might only look at inbound errors and outbound errors, and therefore they would say that this interface is healthy. We're going to say, nope, sorry, the truth of it is that this interface is not healthy. We've got a ton of FCS errors, some deferred transmissions, some outbound discards. And by the way, here's what all of this means when you put together the analysis of these error counters and the configuration is you have a cabling fault. So for example, when you have FCS errors and no alignment errors, that's a cabling issue. If you had FCS errors with alignment errors, but no collisions, you'd be on the full duplex side of a duplex mismatch, either at 10 or 100 meg. So by being able to automatically analyze all this information, you get a plain English answer and can get the problem resolved quickly. Additionally, if you want to learn more about these error counters, we have a built-in engineer's library. Click on the error counter and it gives you the official IEEE definition, a more basic lay definition, and then all of the causes as to where that problem can come from. So you don't need to go out and search Google or Wikipedia to try and find out how do we solve this. All of the information is built in. So with all of this depth of information on every interface of the entire infrastructure, what this means is any packet dropped or buffered or mishandled anywhere in the network, we now know about it. So let's put this together and do a root cause troubleshoot. Let's say we had a problem between somebody's soft phone on a PC and a gateway. Put in the IP address of their PC, put in the IP address of their gateway, and click map. Again, you don't need any agents anywhere. It's going to determine where this PC is plugged in and how that connects to that gateway. And it's going to show us every link, every switch, every router by analyzing routing tables, bridge tables, ARP cache, and spanning tree. Here's the PC. Looks like it's plugged into the Pino layer 2 switch connected to interface number 7. And we're seeing that interface as perfectly healthy. Now, the problem here is that the user said, I had a problem just before noon. Okay, it's not due to this interface, and we can give you confidence that this interface is healthy because it's healthy according to all 19 error counters. Again, other products, if they say an interface is healthy, you want to question, it's healthy according to how many error counters? Because if it's healthy to only 1 or 2 error counters, you don't really know the truth. I've actually seen people fighting problems where they say, my monitoring system says the interface is healthy, but you look at it more closely and find out there's collisions on the interface that it's not detecting. Outbound, that traffic's going out layer 2 switch, the Pino switch, through interface 25. And we can see that that interface had some utilization around noon, but there's more bandwidth available and no packet loss. So that's a healthy interface. Inbound and outbound on the Syrah switch looks good. Uh-oh. Outbound on the Burgundy switch, going out interface number 3, I can see that it looks like right before noon at 11:52 a.m., we were dropping 6% of the packets. Okay, that's suspicious. I click into this interface, read the plain English prescription, and get the root cause of the problem resolved. So it's that fast and easy to find out where we're dropping packets along a path and what the plain English answer is. Now, I'm not going to stop troubleshooting just because I found one interface with a problem, because there might be others. As I keep looking, I realize we're hitting the Santa Clara router and we're dropping a little bit of packets inbound there. It's running half duplex. Okay, that's a quick fix. I can also see that the outbound interface on that router has class-based QoS configured, and there's 2 queues, a high-priority voice queue and a default queue. The problem here is that the high-priority voice queue isn't taking any traffic. That means that all of the voice tag packets are dropping into the default queue. That's bad. Let's see what's going on. We click into the queue, it's going to jump to the interface, show us the queue, and show us the match condition. Oops, that's the wrong match condition. This should be set for DSCP EF. So we make the configuration change to EF. We're going to see that change here. We're going to then start seeing voice tag packets hit this queue. Additionally, we get to see how the queue is built and how it's performing as far as matches and drops here for each of these queues. So this is how we root cause troubleshoot every link, every switch, every router used between any 2 IP addresses with all of the error counters, all the QoS, all the configuration, and all the performance at any point in time during the day. A few other capabilities. For your NOC, you can set up a number of different network maps and be able to see every 5 seconds, what is the status of these links, what is the health and utilization of these links and reachability. The point here is that if something changes within 5 seconds, you know about this. That way, if somebody calls to say, hey, 10 seconds ago, I noticed we lost the Houston site, you can tell them, I'm already aware of that and I'm working the issue, because this will tell you faster than any other solution. We have an automated network diagram that ends up building your network to show here is how your network is connected. Every subnet, every switch, every router, so that you can see how they end up passing traffic. If you want to, you can lock elements in place. So you can move things around and say, here's how I want to have this displayed. But this becomes an automatically updating diagram. In our new version that's coming out in a month, it has Visio downloads. You can download all of these to Visio and have every ability to fully document your network in an automated fashion. The Gremlins tab is the correlation engine. If somebody says the network glitched 15 minutes ago, drop this down to 15 minutes, and you're going to see every event that occurred. Interfaces that change status, devices that change status, interfaces or devices that had high packet loss or high utilization, so that you can quickly understand what glitched at that point in time. Back to the Devices tab. For all of these devices, there's a full set of sub-tabs here. You can see traffic levels. You can see PoE power to see which switches support PoE power, how much power you're using, all of your spanning tree information, topology change on spanning tree, route bridge information, every bit of inventory, manufacturer, model numbers, serial numbers. If you want blade numbers, chassis numbers, serial numbers on that, you can download the spreadsheet and it has all of that information built in. Full internal descriptions, automated backups for all of these devices. Now, if you want to see just the things that are broken in your network, you can go to the Issues tab. This shows everything that's broken. And what we encourage folks to do, they deploy the software, 12 minutes, and then go out to lunch. You come back from lunch, look at this list. It's going to find and say, hey, we found these problems in your network, start fixing them. That way, you're starting to improve the quality of your network within the first hour of deployment and can fix more problems in your network within the first day than many organizations have solved in the previous year with a manual troubleshoot.
A question, Tim?
Yes.
You're getting a lot of detail from a lot of stuff here, like queue information, that kind of stuff. Now, every device out there has a different way of going at getting that information. Do you have a central list of devices you're compatible with and how deep you can go with each of them? Because I'm sure there are some you're not going to be able to get all that detail off of, and some that you just haven't got to yet.
So I'm going to tell you, our company's been around for about 12 years, 13 years now. We have all of that for pretty much every vendor that's out there. We have Arista. We have every model of Cisco. We actually, in our lab, we have some old 3Com hubs that we're able to collect information on. So the queuing stuff is specific to any Cisco device. So all of Cisco's lines, we're getting all of the queuing. But all of the rest of this information, symbol errors, FCS errors, alignment errors, bridge tables, routing tables, all of that, we're supporting Juniper, Extreme, old Foundry stuff. So effectively, our lab is a bit like a dog's breakfast. There's a little bit of everything in it.
Okay. Is there a central list of what you're supporting, however long it may be?
We actually don't have a central list of this. It's basically what we're doing is we're following the code bases, and we have pretty much every manufacturer's code base that we're pulling information off of. If we're during our installation, when we determine, oh, this is a Cisco Nexus 9000, or this is a 4500, or this is an Extreme, old Black Diamond or something, what we do is we interrogate the device to find out what is it, and then we find out what it is capable of giving us as far as its data regarding its configuration. And again, that's that high degree of automation that we've built in so that you as a network engineer don't have to go out with a MIB browser. We do include a MIB browser if you want one, it's included in the package, but you don't have to go out with a MIB browser to say, let me go find out how I can query data off of a device. Those days should be coming to an end. You should be spending your time as an engineer, not building SNMP, but solving problems, because that's really what it's all about.
Well, thank you very much.
Okay. License unlimited Netflow. Any interface that's sending Netflow, you can click in. It's going to be able to tell you what those flows are as far as ports, services, TOS, addresses, and all of the flows. Built-in IPAM. We don't charge for this as a separate module. Effectively, our whole core package has everything I'm showing you. The only thing that is a separate module is our risks tab, which is the security capabilities. So IPAM is built in. You can see how your IP addresses are laid out. We integrate with Microsoft DHCP to show those scopes and scope usage. Switching over to some of the Voip features, we can tell you where your phones are. We're also tracking MOS scores to and from every network device and can trigger alerts if MOS score gets too low. Every one of your QoS interfaces shows here, so you can see what type of queuing, how many queues, and click in to see how the queues are performing. If you have SIP trunks, we can monitor those and we'll tell latency, packet loss, path change out to those SIP trunks. If somebody said they had a problem 2 hours ago, you can look at this and say, okay, everything looks good right now. That's the middle row. But it looks like here 2 hours ago, it was taking an alternate path, and that alternate path had an atrocious amount of latency. Who made the choice to take this alternate path? It was this router that made that routing choice. And we can see this router is part of that provider's network. We can call them up and say, guys, why did your router make this route path choice 2 hours ago? And they'll say, oops, sorry, we had an outage. We had to route your calls through Canada. That attested to why the latency was high. So you can determine if that problem was...
I'm sorry.
Okay. So you can determine if the problem was part of their network, a part of the backbone provider's network, part of your ISP, where along that path that problem happened. So we have a call simulator that's built into the solution. License unlimited. You can run as many of these as you need to be able to validate your network. You can put in any IP address that responds to a ping, and what it's going to do is it's going to bounce a ping using ICMP echo packets that are encapsulated inside of a G711 codec packet and then DSCP tagged, so that we have the exact same footprint on the network of a G711 call, yet you can target anything on your network. For example, here, I'm targeting my default router. Across my default router, I have no loss of DSCP tag, no out of order, low latency, low jitter, no packet loss, and a really good MOS score. Okay, if my LAN proves to be healthy, I can now test across my WAN circuit by pointing to that device. So we're able to determine stability to any location on the network and find out, is it healthy to here? Is it healthy to here? So you can do hop by hop testing to find out, where do we see latency, jitter, or loss coming from. Okay, I have just a little bit I'm going to breeze through on the security side, and then I'm going to open it up to questions. First thing on the security side, I'm going to the risks tab here, and we're going to talk about SOAR. So somebody says, hey, we have suspicions, our IDS said we have some really bad stuff that looks like it's coming from 10.0.0.10. Put the search here, it's going to tell us that device is plugged into the Syrah switch interface 23. We can click here, it's going to find the Syrah switch interface 23, and we can see, yep, 10.0.0.10 is connected there. We can learn that it's connected with, associated with the default VLAN, it's a Dell computer, and it has a name of Daphne. We can do a quick port scan and click connect and find out this thing responds to SSH and web requests. And we can click here, it will launch the browser's SSH client or launch a web page into it to find out what is it. If we want to, though, we can do a more in-depth scan if you have Nmap installed on the computer. So we integrate with Nmap. You can end up doing a scan. It will run the Nmap and show, here's the results of that scan. This is starting to look like it's a Microsoft computer that's plugged in there. Now, in our case, we don't even need to do that. Because we're integrated with Active Directory, we've determined that the Daphne computer is already a member computer of the domain and will show you a domain link. Click on the domain link, and we're going to tell you, oh, it's a Windows 2016 server, it's a virtual machine, Here's the CPU, here's the RAM, here's the network I/O and disk I/O. Here's who's logged in. You can see what their rights are, what their capabilities are. You get to see processes to say who's running processes on the box. What are the flows? Who is this box communicating with? And where do those flows go to? In this case, this box is communicating with Salesforce. That's fine. It's also communicating with some server in England that's off of Virgin Media. So you get to see what the risks and communications are with that box. Now, if we have enough indications of compromise that we say, yeah, this needs to be cut off the network, we can come over here to the control and do shutdown and shut the port down. Going back to risks, we have network device vulnerabilities. We can detect what the vulnerable device operating systems are in the environment. We have a Cisco ASA here running 8.2 Rev 1 with a critical vulnerability. We get to see what that critical vulnerability is, along with a full description and the CVE ID number. We can click on the CVE ID and it will go out to NIST and show us all of the details about that vulnerability. So every ability to research and have that answered in one tool, and you don't need to do fingerprinting or scanning. For risks, you get to see all of the exposures in the environments. Uncontrolled DNS, for example, we can click here and see these are all the computers that are not using your corporate DNS infrastructure. They're going directly out to Google, or they're using 1.1.1.1. That way you can go out and fix these so they do use your corporate infrastructure. We also expose geographic risks. You can whitelist and blacklist various countries to say, hey, what are all this communications going out to Nigeria? Must be that prince that we're interacting with. You can click and it's going to show you all of the flows that go to Nigeria, where it's coming from, and which machine and how it's going out. In this case, this machine has a vulnerability or an exposure. It's sending data out via SQL. So that's pretty much it on the risk side. One thing really quick I'm going to still cover is cloud service monitoring, just like the SIP trunk monitoring. We can do cloud service monitoring the same way so that you can see what your stability is to all of these cloud services. So at this point, I'd like to open it up to questions.
So where are you getting your the flow monitoring that you're doing for all the devices? Could you just tell me again where you were getting all the flow data from?
So flow data will come from firewalls, switches, and we support Netflow, IPFix, SFlow, JFlow. So any of the flow technologies, if you just program your switch, program your firewall to send us flow data, we're going to ingest that and automatically just report on that.
Okay, so you're basically, you'll act as a collector. We'll throw stuff at you and you'll ingest it.
Yes.
Awesome.
And on that Netflow, is it possible to search through the Netflow data, or is it only you bring it up per interface, or wherever you're dug in?
You can bring it up by device and say this device, who does it talk to? You can do it by interface and say what is all the flows going in and out of this one interface. You can look at it both ways. We don't have a search for the flow database, but that is on our roadmap for 13, not 12, but 13.
And Tim, I heard you say a number of times throughout the presentation, I think you said license unlimited. So I wonder if you can talk about sort of the licensing for this product and what we get.
So we make it really simple. Instead of saying, gee, you need 10 server monitoring licenses, 18 Netflow monitoring licenses and IPAM and all this sort of stuff, what we've done is we said, make the licensing simple so that network engineers can say, I want to be able to see if I can afford this. Give me a real simple quote. All we need to do is total up the number of interfaces in your environment. And what I mean by interfaces is count up your switch ports, count up your router ports, give us that number. So if you say, hey, I've got 2,500 total interfaces, total ports in my environment, we get you a price quote on that and you're done. If you find out that you say, gee, I think ballpark it somewhere around 3,500 or 4,000, what we're going to do is say, okay, that's easy. We're going to sell you 5,000 because that's the next price break point, and it's less expensive to buy the 5,000. So this makes quoting really easy so that you can just say, give us a ballpark, we'll get you the price, and the price is not ridiculous compared to a lot of other solutions. It ends up being very easily purchasable, where a lot of folks will say, well, gee, I've got this mainline monitoring system, it's monitoring, but we're not going to replace it. How can I augment my troubleshooting? Our price is low enough where folks can say they'll get us for the troubleshooting so that they use us to be able to solve those VoIP problems, those call quality problems, those problems you can't solve through a regular monitoring solution.
And I'm just wondering, sort of, what is the smallest sort of port count that you've seen this product used for? I'm just wondering, sort of, what level of business this is a good fit for.
So 250 interfaces, we've sold those sorts of licenses, and those licenses, are the size that I can't quote a specific price, but they're generally the size that you can put on a company credit card. So again, not ridiculous pricing.
Got it. Thanks.
So, question about the network discovery. You're obviously, I'm guessing, doing sweeps for IPv4 stuff. What are you using for IPv6 networks? Just neighbor discovery stuff?
So in one sense, I'll admit to you, we're not doing a lot in the world of IPv6. We've kind of asked a lot of our customers, and they're choosing to go dual stack, or they're choosing to say this is internal, and they're not doing a lot of IPv6. So we haven't really done a whole lot there yet. We've been watching it closely. And so far, we haven't had customers say, gee, we're not buying because you're not doing IPv6 yet. I know this is kind of a religious argument for some folks, but we do want to do it, and we do have some hooks that we've built to allow us to get into the IPv6 stuff, but we just haven't done that yet.
Okay, thank you.
Well, if you guys want to get a look at this, go to www.pathsolutions.com. There's a demo you can go through on the site. There's videos you can see, and you can also reach out to us, and we'll give you a technical presentation, and we can get you a proof of concept.